In the ninth question, we are using the dataset county murders, and we have to use the data only for the year 1996. So in the first part, it says how many counties had 0 murders in 1996 and how many counties had at least one execution. What is the largest number of executions? Estimate the equation murders being explained by executions. Okay. And in the third part, it says interpret the slope coefficient reported in part 2. And in the fourth part, it says what is the smallest number of murders that can be predicted by the equation. And in the fifth part, it says explain why a simple regression analysis is not well suited for determining whether capital punishment has a deterrent effect on murders. The first, load the data set murder equals to woo.data in the bracket county murders. Now we have to filter the data only for the year 1996. For this, create a new data frame murder underscore 1996 equals to murder, and in the bracket murder again, and then type the column name year equals to 1996. So we have now the new data frame only for the year 1996. Now let's count the number of counties with 0 murders and at least one execution. For 0 murders, use this command murder underscore 1996 in the bracket. The murders column should be equal to 0 dot sum, and at least one execution, type the column name execution greater than 0 dot sum, and for maximum execution, type the dataset name and then in the column type executions and then dot maximum function. So counties with 0 murders are 1051, that is 1051. Counties with at least one execution is 31, and maximum executions in any county is 3. Now let's estimate the OLS regression. Create the model name model equals to smf.ols in the bracket formula equals to murders being explained by executions. Type the dataset name murder and then dot fit function. And for the results, type print model.summary. So in the regression results on the right hand side, you can see the intercept is 6.83 and the coefficient on executions is 65.46. Okay, so let's interpret the slope coefficient. What is the meaning of this coefficient 65.46? It means that each additional execution is associated with 65.46 murders. That is, executions positively impact the number of murders in a county. Now in the fourth part, we have to calculate minimum predicted murders and residuals for 0 executions. To create a variable minim underscore predicted equals to model.predict, type the dataset name murder.minimum. So this will give us the minimum predicted murders, which is 6.83. Okay, and now we have to predict residuals for 0 executions. So create a variable predicted underscore 0 underscore exec equals to model.predict. In this bracket, round bracket, type pd.dataframe and then use curly bracket. Use this column name execs because we are calculating for 0 executions, so execs should be 0, and then multiply this command by 0 in the square bracket. So this will give us one value where executions is 0. Now we have to calculate residual for 0 execution, that is actual minus predicted 0 execution. So create this variable residual underscore 0 underscore exec equals to 0 minus this value predicted for 0 executions. So minimum predicted murders is 6.83 and residual for country with 0 executions and 0 murders is minus 6.83. In the last part, the question says why simple regression is unsuitable. So the simple regression in this case, in this question, might be unsuitable due to other factors, due to many other factors, such as omitted variables. We may have left many socioeconomic factors which might affect murders. And similarly, there can be other causes as well, such as endogeneity, reverse causality, count data limitation, etc. So this question is done. So let's move on to the next question. In the 10th question, we are using the dataset Catholic, and it includes test score information on over 7,000 students in the United States. And the variables Math 12 and Read 12 are scores on 12th grade standardized math and reading tests, respectively. So the first part of the question says, how many students are in the sample? Find the means and standard deviation of Math 12 and Read 12, and then run the simple regression of Math 12 on Read 12 to obtain OLS intercept and slope estimates. In the third part, it says, does the intercept reported in part 2 have a meaningful interpretation? Explain. And in the fourth part, it says, are you surprised by the beta 1 hat and that you found? What about R squared? So let's begin the question. In the right hand side of the screen, you can see the solution or the results of the code, and in the left hand side of the screen, you can see the code. So first, load the data set by creating a data frame called cath equals to woo.data in the bracket Catholic. Then first part of the question, it says count number of students and compute means and standard deviation. For number of students, we have to calculate the number of rows. For this, type the dataset name cath dot shape in the square bracket, type 0. It will give you the number of rows. Now mean of Math 12, select the dataset name and then select the column in the square bracket Math 12. Then type the dot mean function. For standard deviation, select the dataset cath in the square bracket, type the column name Math 12 and then std for standard deviation. Similarly, you have to repeat this process for the column Read 12. So in the right hand side, you can see that the total number of students in the dataset are 7,430. Mean of Math 12 is 52.13. Standard deviation of Math 12 is 9.45. And mean of Read 12 is 51.77. And standard deviation of Read 12 is 9.40. Now let's run the OLS regression of Math 12 on Read 12. So create a model equals to smm.ols, and the formula, type Math 12 tilde Read 12. Math 12 is being explained by Read 12 and the dataset name is cath.fit function. Let's extract the values from this regression analysis. Beta 0 equals to model.params in the square bracket, type intercept, and for beta 1 equals to model.params in the bracket square bracket, type Read 12, and R squared is model.R squared. So here you can see the regression results. Math 12 is equal to 15.15 plus 0.71 into Read 12. And number of observations are 7430. R squared is 0.50. It is greater than 0.5. So it explains much of the variation, much of the sampling variation in the data. And the intercept is 15.15 and the beta 1 is 0.71. Now we have to interpret the intercept. The intercept 15.15 suggests that if a student's reading score is 0, their expected math score is 15.15. However, since reading scores are close to 0 are unrealistic, the intercept has little practical interpretation. Okay, so now in the fourth part, it says evaluation of slope coefficient and R squared. Slope coefficient is 0.71. It suggests that an increase of 1 unit in reading score is associated with an increase of 0.7143 in math score, and the R square value is relatively high, meaning a strong correlation between reading and math scores. Now, response to superintendent's comment. See, a correlation does not imply causation. Just because math and reading scores are correlated, it does not mean that improving reading will automatically improve math. Many factors contribute to math scores, such as school quality, socioeconomic status, and study habits. Now we have to run a reverse regression of read 12 on math 12. So create a new model by the name of model underscore reverse rev simply equals to smf.ols, and in the formula read 12 tilde math 12. So in this case, read 12 is being explained by math 12 in the data type cath and dot fit function. Now extract the values from the regression analysis. Create new parameters beta 0 underscore rev equals to select this new model name model underscore rev dot params, and then in the square bracket type intercept. For slope, you have to type in the square bracket math 12, and for r squareds you simply have to uh, you have type the new model's name model underscore rev dot r squared. So the results are as follows of the regression of read 12 on math 12. So r squared value is similar to the previous model, 0.5047, and the intercept in this case is 14.93, and the beta 1 in this case is 0.7066. So the values of this regression are also similar. So what is the conclusion? The bidirectional relationship suggests correlation but no clear causal mechanism. So we are done with this question. So let's move on to the next question. In the last question, we are using the dataset GPA1. It is a sample of Michigan State University undergraduates from the mid 1990s and includes current college GPA, which is called call GPA, and a binary variable indicating whether the student owned a personal computer. First part says how many students are in the sample, find the average and highest college GPAs. Second part says how many students own their own PC. And the third part says estimate the simple regression equation call GPA being explained by PC and report your estimates for beta 0 and beta 1. What is R squared from the regression? And in the last part it says does your finding in part 3 imply that owning a PC has a causal effect on call GPA? So first load the dataset GPA equals to woo.data GPA1. First part, number of students, average and highest college GPAs. So create a new variable num underscore students equal to select the dataset and then type dot shape in the square bracket 0. It will give you the number of rows. For average and maximum college GPA, select the column call GPA and then type the mean function and max function. So total number of students in the dataset are 141 and average college GPA is 3.05 and highest college GPA is 4.00. Now we have to count the number of students who own a PC. So create a new variable num underscore PC underscore owners equals to GP. Select the column name PC, then dot sum. Or we can also use another function called another method called value counts, value underscore counts. Select the dataset GPA and then the column PC, then type dot value counts. So in the previous method, sum function, it will give you only the number of students who own a PC, that is 56. And this second method, value counts, will give you the results for both the students who own and who do not own a PC. So in this case, you can see on the right hand side, 0 indicates that students who do not own a PC. So the number of students who do not own a PC is 85 and the number of students who own a PC is 56. Now we have to run OLS regression of call GPA on PC. Create a model name model equals to smf.ols. In the formula type call GPA tilde PC, that is call GPA is being explained by PC. Type the dataset name GPA dot fit function. Extract the values for beta 0 and beta 1 by typing beta 0 equals to model.params in the square bracket intercept, and then for beta 1 model.params in the square bracket PC, and then r squared equal to model.r squared. So the intercept of the regression analysis is 2.98 and the beta 1, that is the slope, is 0.16 and the r squared value is 0.05. Okay, so interpretation of r squared. The r squared value 0.05 is quite low, suggesting that PC ownership explains very little of the variation in call GPA. And coming to the interpretation of the does PC ownership have a causal effect on call GPA? The regression shows an association between PC ownership and GPA, but it does not establish causality. There may be confounding factors such as students with higher GPAs being more likely to afford a PC, A better approach would be a control experiment or using an instrumental variable to address endogeneity. So we are done with this question and we are done with this chapter. So we will meet soon again for the next chapter, computer exercises. Thank you. Thanks for watching. If you found this helpful, don't forget to like the video and subscribe to the channel for more content like this. See you in the next one.